So, with all this math out of the way, let's recap again the key ideas of backpropagation. Our goal and motivation is to calculate all partial derivatives for each weight. And we notice that we can express these partial derivatives with the error signal. Computing the error signal is very simple for the neurons in the last layer, since the loss function is in a very close relation to the drive of those neurons. So when we ask how their drive affects the loss, so what the error signal is, then we get a very short answer. And so for the last layer, the error signal consists of the derivative of the loss function with respect to the activation, that is that part here, and that is multiplied with the derivative of the activation function, so that part here. The loss and activation function are not set in stone. So if you remember in the previous video, our derivative of the loss function had something with 2 divided by m, and here we have only a minus in front of our brackets. And this is because we're using the normal squared error here. And so we can use all kind of loss functions, so for example cross entropy or categorical cross entropy. And then we just take the derivative of that. And the same goes for our activation function. So this sigma here could be a sigmoid or something else. And so with the error signals of the last layer, we can update the weights of this layer. Because the weight update of our neurons is just the error signal of that neuron multiplied by the activation of the weight's origin neuron. So the error signal is multiplied by the activation, that gives us the weight update. And looking at our network, this is for example, we have for example the error signal of this neuron, and then multiplied with this activation here, gives us then the weight update of this weight. Now we can take a step back into the n-1 layer. Here we can define the error signal of our neurons based on the error signals of the earlier layer that we just calculated. This is what is described here. So for the error signal in this neuron, for example, we will multiply this weight with this error signal and this weight with this error signal, add them together, so that's that part here, and then we multiply the whole thing with the derivative of the activation function of our drive, also in that neuron here. And that gets us this error signal. And we can repeat this for this neuron and this neuron. And so now we have the error signals of the whole layer. And with them we can again calculate the weight updates. We can repeat this backpropagation for the remaining layers or layer. What's important is that for the first layer, so for this layer here, we don't have any activations coming from any neurons. And so instead we'll use the model inputs. Okay, so now as a whole, first we do the forward pass with our input. So we go through the layers and we obtain our output, so our y hat. With our y hat and also with our target, we calculate the loss. And based on the loss, we do the backward pass, where we calculate the error signal for each layer, and then based on the error signal, update the weights of these layers.